Hi, this is another example from Iran Mathematical Olympiad Round 1 in 1997. So let's look at the question. We have two equations, x, y, and z are member of z plus. The question is how many sets of x, y, and z we have that fulfills these two equations. In the original question, it was not mentioned positive integer. It was mentioned only integers. However, when you solve the question, you realize that none of these answers will be a solution if x, y, z are member of integers. So I decided to narrow it down to z plus, so one of these answers will be a solution. In the exam, you would get approximately 6 minutes to solve this exercise. Maybe you can spend 10 minutes, and after that, come and watch the solution. All right, so here are the two equations. We can subtract them. Z disappears, x minus y, y2 minus x2, and we can factorize this y minus x to y plus x. And now obviously we can factorize y minus x. This one, y plus x, will be remaining. This one become minus 1 is equal to 24. Now we can write 24 as product of two numbers. We have multiple cases, so it can be 1 times 24, or it can be 24 times 1, 3 times 8, 8 times 3, and so on. Also all the negative combinations, so minus 1 times minus 24, minus 24 times minus 1, and so on. Okay, so here is the equation. We have these possibilities. Now let us look at each individual terms. And if we add them together, what happens? So obviously x will disappear. And if we add them together, we get 2y minus 1. Now what conclusion we can draw from this is that both of these numbers cannot be even. Because if they are both even, when we add them together, it should also be even. But this is an odd number. That means we can get rid of all these possibilities because both of them are even. So now for any of these scenarios, we can actually find a solution. And therefore, the final answer of this exercise will be 8 sets of x, y, z. However, since I narrowed it, we only can accept x, y, z that are positive. Let's see what to do. So we have 2y minus 1. Of course, it's addition of these two because one of them is this one of them is the other one. So if we add them together, this is 25, this one becomes 25. If this is the scenario, this becomes minus 25, this is minus 25. So 2y minus 1 can be plus minus 25. And for the other cases, it can be 11 or minus 11. Now for any of these cases, we can calculate the y. So for example, if this is 25, minus 1 goes there, 26 divided by 2 is 13. Or if it is minus 25, become minus 24 divided by 2 minus 12. And the same way here, we can get 6 and minus 5. Now, obviously, because I said x and y and z should be positive integers, so these two cannot be a solution. And these two were corresponding to these cases. None of them could be a solution. Again, if all of them were member of integers, each of them could produce a solution at the end. So we would get 8. But now this one disappears. All right, let's continue. So we have two scenarios. Either y can be 13. We have two cases. Y can be 6. We have two cases. So we have 4 scenarios in total. Let's take this one. So y minus x is equal to 1. Y is 13 minus x is 1. So x will be 12. The other case, y minus x is 24. 13 minus x is 24. X become minus 11, but this is not acceptable because it's a negative. For this case, y is positive, x is positive. We have to calculate z. These are the two equations. We should calculate z actually for both of them to make sure that we get the same value for both equations. So here we have x is 12, y is 13, and then this gives us 57. Same way, it gives us 57, so this is a correct answer. Therefore, one set of x, y, z will be 12, 13, 57. Again, if x, y, z could be a member of integers, then this would be also a possible solution, and then we could find z for it. Second case, obviously, is this one. Same way, y minus x is equal to 3. This one gives us x equal to 3. Y minus x is equal to 8. This one gives us x minus 2, which is not acceptable. And now I take this case, put it inside the equations, we conclude that z should be minus 85. This is again not acceptable because the z is a negative number. All right, so we get to the end of the solution. Basically, the answer would be 1 in this case, if x, y, z are member of z plus. If x, y, z are member of z, then the answer would be 8, which actually is not given in any of these options. Okay, so what we have learned is that in certain cases, we can express an integer as products of other integers. And by this way, we can generate extra equations, which can help us to solve the questions we have. And obviously, we should use basic integer properties to narrow the range of possible solutions. For example, if we add two even numbers, the solution will also be an even number, and so on. All right, so that's the end of this video. See you next time. Bye.